That look like science fiction? Brave New World? It shouldn't. There's nothing more natural to the human experience than to be able to take data in from our 5 senses at 11 megabit per second, to be precise, and use it to interact with and learn about the physical world around us. There's a great book called 1,000 Brains by Jeff Hawkins that hypothesizes that human intelligence evolved because of our need to be able to interact with the three-dimensional world. Now think about it. If you forgot where you put your food, or where you last saw that predator, or what happened when you stuck your hand in a fire, you didn't survive, and you lost out on the evolutionary sweepstakes. So we think that artificial intelligence can evolve in much the same way, by the constant infusion of data from Internet of Things. A friend of mine at ARM likes to talk about, if generative AI is the brain, IoT is the nervous system. Now, last year, there were roughly 2 connected IoT devices for every human on the planet. And in the next 15 years, we expect that number will increase by about 2.5 times. And these IoT devices bring in all kinds of data. Telemetry from industrial machines, farmers' fields, connected vehicles on the road, video from the cameras that you use to protect your home or your place of business, point clouds from LiDAR that help a vehicle navigate through a highway with obstacles and pedestrians, and then the frequency, amplitude, and phase from vibration sensors that you may have on any sort of piece of industrial equipment or anything that moves and costs a lot of money. Now, this enables what we call multimodal learning, which is really just a fancy expression for what, again, we humans have been doing for millions of years, almost literally. For example, your ears detected the thundering herd of elephants before your eyes detected them cresting the hill, and your brain decided what to do to avoid this situation. Or you could smell the smoke from a fire before you feel the heat and realize you need to go in the other direction and be able to protect yourself. So there's nothing new here, right? What's new is that the pace of innovation to make use of IoT data infusing AI systems is really accelerating in some critical industries. Whether it's drug manufacturers being able to manufacture pharmaceuticals more safely, more quickly, more effectively, whether it's a manufacturing plant working on quality, cost reduction, throughput efficiency improvements, whether it's us in our homes being able to not only keep ourselves secure and safe, but to have a little bit more of a lifestyle. For example, knowing when my dog jumped on the couch and telling her to get down. Or when you're driving in a car, or even better, having the car drive you around. These are important problems to solve. And as much as we all enjoy making pictures of ourselves dressed as superheroes, or using facial recognition on a school of fish, I'd humbly suggest that solving these problems will make the world a better place. And they all depend on IoT. Now, what should you expect from a system that has been properly infused with IoT and using generative AI to its fullest extent? Again, there's that multimodal data fusion concept. For example, if you're tracking a container of goods across the water, you need to know where it is, probably using satellite location and communication. You may want to know the temperature, the humidity, the pressure of various other sensors inside the container to be able to check in on the quality of the goods that you're shipping back and forth. Root cause analysis gets a lot more complicated as our toys get more complex. Being able to debug a problem for a piece of equipment in your home when you're trying to fix your internet router on the phone with a call center representative who may have access to the data that's streaming off of your router, or be able to go check into it and be able to extract telemetry and help you fix the problem yourself, that will avoid a very costly home visit by your internet service provider. Adaptive anomaly detection. I'll put in a quick plug for my talk later this afternoon, IOT205. We're going to talk about how you can use water meters data, water flow sensor data, to be able, and AI to be able to chew through a histogram of how much water a family of 5 ought to consume, and then be able to detect when it's most likely that your sprinkler's broken or you have a run-on toilet. Happened to me, it cost me $900. Dynamic query handling is a little like having a superhuman on your shoulder. So if you are a technician and you need to be able to debug something on an assembly line, in someone's home, out in the field, possibly in a hazardous situation if you're climbing an electric tower, it's good to have a well-educated chatbot or buddy that has been schooled on all the different types of failure modes in the piece of equipment that you're troubleshooting, that can understand your questions in natural language and respond to you quickly. Subject matter experts, being what we are, tend to know a lot about a little, whereas a generative AI system could know a lot about a lot. Explainable alerts and insights. We probably all know what 404 means by now. There's a lot of other unparsable error codes in the world today. Wouldn't it be nice to hear from your system something in natural language to help you understand what might have gone wrong and how you might fix it? Now, what are some of the challenges in building a system, or rather, what are the things that you ought to look for in a well-designed generative AI system that has the right amount of IoT data connectivity into it? Obviously, IoT generates a ton of data. So the system's ability to be able to deal with this in real time and parse it all and filter it and discover what's useful in it that can be used is critical. One thing humans are quite good at is the ability to make connections between disparate concepts. In fact, some people think one of the key measures of intelligence is the amount of interconnections in the brain that fuse things together. This is a difficult problem to solve with a computer, but it's going to get solved. And as it does, the number of different concepts that can be compared and contrasted will be able to help the computer solve far more difficult problems. Scalable and cost-effective infrastructure. AWS is spending enormous amounts of capital equipment to be able to build the compute infrastructure necessary to power generative AI across the globe. And finally, we take a lot of time and a lot of care to make certain it's done privately and securely. This is something I have higher hopes for in the artificial intelligence world than I do in the natural intelligence world. Now, we have obviously a broad set and deep set of services at AWS to help you build these systems. From our device runtimes and operating systems that allow you to build cost-effective, intelligent sensors at the edge, to our data ingestion engines that can manage multi-million device estates and be able to update them, secure them, restart them, and manage the life cycle of application components on those devices, to all of the different ways that AWS can process streams, store data, convolve data with different types of data streams, and be able, again, to fuse things and integrate things together to be able to derive greater insights. And then you've heard a lot of announcements this week about our machine learning training capabilities with SageMaker, our platform in Bedrock that supports multiple LLMs, including a number that we have announced this week. And all of our business intelligence tools that allow you to make sense of this massive amount of data that comes in to inform us about the physical world. So today, we're going to talk about 3 different design patterns, if you will, around AI plus IoT. The first is a simple analysis, or rather complex analysis. How do you analyze more difficult problems than we could before? How to make assistants. Again, in a later talk, we'll discuss digital interns. Again, those chatbots, those superhumans on your shoulder that can help people solve more sophisticated problems more quickly, more efficiently, and make us all more productive. And then finally, autonomy. How do you build things that can make decisions themselves? Again, informed by physical world data, just like we do. So I'll give you a quick example. Let's say you are in charge of a manufacturing floor. You could be building MRI machines, you could be building multifunction printers. Today, there's plenty of tools that you can use to be able to manage the efficiency of your manufacturing system. We can collect data on machines whose age can be measured in decades, and we can clean that data and harmonize it into a framework or into a model that then can be analyzed by the tools that we have and looked at by a subject matter expert. So at the end of the day, you can have multiple reports about different machines on your factory floor and be able to understand how well they're working, to be able to predict failure, to be able to schedule maintenance. All good. Now, a couple things could be better. Those reports, being tied somewhat to human subject matter experts, can be a little bit siloed. They also take a little time to generate. If you only generate a report at the end of the day, whatever problem you found early on, you're going to live with for the rest of the shift. Now enter AI, where the subject matter experts have a much broader range of expertise due to the greater amount of data they can be trained on and the greater compute capacity that they have. Reports can be generated in real time so that as problems occur, they can be mitigated and resolved, and you can continue operating your factory as you like. And then finally, instead of getting specific reports about an individual piece of equipment or a line, you can get much more integrated, holistic insights about how your factory operates. But don't take my word for it. Let me introduce you to somebody who deals with this every day. Peter, would you like to come up?
Thank you, Dave. My name is Peter Obradovic. I'm the head of R&D for HP Industrial Print Software Solutions, and I'm here to tell you about exciting work we're doing together with AWS in the domain of industrial print, IoT, and automation. The invention of printing has been one of the most transforming forces in human history. From early woodblock printing thousands of years ago in China to the revolutionary Gutenberg press, ability to replicate written text rapidly changed the course of civilization. Prior to printing, the spread of human knowledge was extremely limited. It was confined to oral tradition and to hand-copied manuscript. Printing democratized information. It fueled movements like Renaissance, Reformation, scientific revolution. It made books and knowledge available to broad audiences. It facilitated the spread of political, scientific, religious ideas, paved way to literature, newspaper, and mass education. Still, until few decades ago, industrial printing was analog, meaning once the impression plate, the physical impression plate was made, it wasn't possible to change it. Every print was the same, and that severely limited the possibilities. Luckily, all this changed with the invention of a digital press. The first digital press was HP Indigo Digital Press, and it was a game changer. It made it possible for every impression, every print to be unique. And that made it possible to deliver highly personalized, highly targeted content, to drastically reduce delivery times. It made possible to cost-effectively fulfill a very short print orders. It reduced inventories. It minimized environmental impact. Today, industrial digital print is the fastest growing segment of an $820 billion print market. Of course, today we have more effective ways to distribute information, but printing continues to be extremely relevant and continues to evolve thanks to a broad range of applications and possibilities. Large format printing enables us to wrap the world around us in vibrant messages. Look around this amazing conference and you will see the panels, the signage, the posters, all result of large format printing. Commercial printing makes it possible to deliver highly personalized, highly targeted messages, to inform, to preserve and share memories, to recognize, to celebrate. The fastest growing industrial digital print, specifically around areas of labels and packaging, is revolutionizing how brands engage with consumers, how they differentiate, how they drive efficiencies, how they track their products through complex supply chains, and how they protect their products through the use of secure printing. It's virtually impossible to imagine the world today without printing. Try to imagine walking into your favorite supermarket and seeing aisles and aisles of completely blank packaging. No color, no graphics, no text. It doesn't work. But to make this exciting work of industrial print possible requires very sophisticated, very complex manufacturing processes. Manufacturing processes that often take place across football field size or larger manufacturing facilities that are being fed by numerous supply chains delivering both raw materials and information to be printed, that's dealing with ever-increasing number of daily orders and jobs, that consists of dozens of hardware, software solutions, that has numerous steps and participants in the production chain, that consists of both digital and analog devices. Producing modern high-impact print is very challenging. And our customers, print service providers, the manufacturers of print, need help. They need data to understand what is going on. They need insights to plan. They need tools to manage and adapt when things do not go per plan. About 10 years ago, HP recognized many of these challenges and started on the journey to revolutionize the world of industrial printing. This is the same time when our collaboration with AWS started, and it's been an invaluable collaboration ever since. We took our solutions, we migrated them to the cloud, we connected all of our devices into the world's largest IoT network of digital presses. We delivered new solutions that helped our customers understand and improve their productivity, maintain their equipment, ensure the highest possible quality output consistently, make and produce amazing designs to be printed. We connected our customers, our partners globally, enabling them to collaborate effectively. It's been a very successful journey for us. We have an active community of users. We're operating the world's largest network of digital presses. But to address all of the problems that we've been discussing earlier, even more is needed. Earlier this year, HP announced plans for intelligent automation, an intelligent printing factory of the future. The vision where the entire production floor is automated end-to-end, where the planning happens automatically, the issues are anticipated and resolved before they actually happen, all while improving efficiency and profitability for our customers. To help us on this journey, we use this, we call it a circle of intelligent automation. As is often the case, the journey to intelligence and automation starts with data. Collecting the data from the entire production floor, transforming that data to information, feeding the information into algorithms, AI, ML models to turn it into knowledge, delivered as insights and recommendations. That first part of the circle we refer to as what. What has happened, what is happening, what should happen next. In parallel, we're working to address the integration challenges across the entire production floor. This is the part that we refer to as how, ability to take actions across the production floor. The what and the how together give us the key ingredients to deliver on the vision of intelligent automation. To make all this a reality, we yet again turned to our partners at AWS. The challenge this time wasn't connecting modern software solutions and digital presses that HP has built. The challenge was to connect the entire production floor that has hundreds of devices from many different vendors with different data models, with different communication protocols. We got together with AWS, we communicated our requirements, ability to collect all this data from the edge, to push it into the cloud, and do it all in a regulatory compliant, reliable way. Very quickly, services like AWS IoT Greengrass and Sitewise emerged as the top candidates to meet our requirements. We worked very closely with AWS team. They even adjusted some of their plans and roadmaps to meet our requirements. We got going. We were getting regular, weekly, sometimes even daily drops on the way to implementing our solution. HP benefited greatly from this collaboration. It enabled us to focus on our domain of expertise in industrial print and to heavily leverage from capabilities in AWS. We were able to leverage deploying and pushing the software to the edge, connecting and managing all of these devices, getting support for communication protocols like MQTT and OPC UA, modeling all of these diverse devices as assets in Sitewise, creating data models that helped us map from vendor-specific data and transforming it into our domain-specific data. We were able to leverage AWS cybersecurity solutions, replicating all of our secrets management from the cloud directly into the edge. And of course, at the end, we were able to stream all of this information into the cloud in a very reliable, resilient way, being able to handle unreliable connections by buffering on the edge. We estimate that this significantly reduced our time to market. As a matter of fact, we went from a concept to a production-ready solution we demonstrated at a trade show in some of our largest customers in less than 6 months. Now, so far we've made it, at the first few steps on our circle of intelligent automation. The next step is to move all the data into the cloud, to continue to use a broad range of AWS and third-party services to continue to transform the data, to build new algorithms, new AI and ML models, both traditional and generative, to drive these insights and recommendations for our customers, to take those data models and deploy them back into our AWS production environment and make them available to our customers and our partners. In summary, we have an amazing relationship with AWS that's been going on for over a decade. It enables us, the HP, to focus on our domain of expertise. We have a direct, ongoing communication with AWS teams. Often we've seen them willing to change their plans to meet our requirements. We're getting ongoing drops weekly, sometimes even daily. We know we can rely on reusing proven AWS technologies and well-established architectural patterns. Our estimate is that the collaboration with AWS accelerated our time to market by about 50%. And with that, I'm going to turn it over to Jeremy.
It's always exciting to see what you're up to there at HP. So my name is Jeremy. I lead our team of IoT solutions architects, and let's continue our discussion around the emerging patterns with IoT and AI. So next up are assistants. So I'm sure everybody in the audience today has had a chance to interact with a generative AI assistant. You know, using a simple natural language request or prompt, generative AI assistants can help respond to complex queries and tasks. There's a wide variety of different use cases for generative AI assistants, but there's a couple that are particularly interesting when it comes to IoT data. So first are industrial assistants. Industrial assistants are making it easier to manage and optimize the factory floor. And this is by combining data across disparate systems, sensors, and equipment, those machines and set of equipment on the factory floor, with a knowledge base of documentation and equipment manuals and systems level awareness that give operators a better insight into what's going on the factory floor. Next, our vehicles are becoming more and more intelligent with new features for driver assistance, self-driving, self-parking, and more. The next generation of these vehicles are coming out with AI assistants that can provide information about themselves. So that's things like your driving habits. It could be, you know, when to take your car in for maintenance. Third, technicians are getting an expert eye that comes along with them on site when they're installing equipment. By providing directional guidance for installation, operation, and repairs with contextual data such as past customer cases through support, installations can go a lot more smoothly. And finally, our connected products are really evolving into connected experiences. So think of all the smart TVs, lights, and robot cleaners that are out there. They're evolving into these connected experiences that are across setup, configuration, operation, and customer support. And AI assistants can be used across these dimensions to reduce friction between people and our technology. And this year's been a very exciting year for customers building these AI assistants on AWS. So first, Bosch Connected Industry is a leading provider of Industry 4.0 solutions, and they provide their customers a pathway to digitize industrial operations. And today they offer a digital twin solution. This is and in that digital twin solution, they have an AI assistant that's built on AWS Bedrock. This solution provides operators a real-time view into what's going on the factory floor, and enables operators to provide proactive remedies for failures, root cause analysis, and more. Toyota has made their vehicles experts on themselves. And this is pretty exciting because now owners, when they're in their vehicle, can get provided information about the icons of the console and what they do, as well as the vehicle's health when it's time to bring your Toyota into the dealer. Finally, Kone, and if everybody when you're on an escalator in the hotel today, take a look down, you'll see Kone's logo. Kone has over 30,000 maintenance technicians that make 80,000 customer visits per day on average. And this really helps keep our cities flow. Kone's 24/7 connected services, which are built on AWS IoT, provide the data from those set of equipment, when coupled with things like a knowledge base of service history, fault codes, and other insights, the technicians, when they're on site, can more quickly diagnose and solve the actual problems at hand. All right, so let's dig into our second architecture pattern. This one's for improving connected product experiences. So we just got through Black Friday, and I'm sure all of you went online to buy some things at a good price. It could have been a smart home product, such as a robot vacuum. So let's imagine you got that smart home product, you unboxed it, you got it set up, and you're thinking, great, if it's a robot vacuum, I don't need to vacuum these floors today. However, a few hours later, you realize the vacuum stops working. Think about how frustrating that is. The product was supposed to provide you this convenience, and now it's not able to vacuum your floors. What if that problem could be resolved immediately or even proactively? So on the left of this diagram, you see connected products that are capturing telemetry and diagnostic data using our AWS IoT suite. That data can be processed at the edge, pre-processed, and then streamed into the cloud to the best fit data store. Now that the data is in AWS, it's available to Amazon Bedrock through our suite of generative AI tools. Bedrock, through using our tools around developing agentic workflows with Bedrock agents, can now run things like diagnostic checks in line with the chat agent that's communicating with the customer. This, when combined with a knowledge base of config files, device documentation, and more, the root cause can be immediately identified with a personalized response that's sent to that customer with step-by-step guides on how to solve the problem. Now, the customer's delighted as they're able to solve their problem immediately. However, customers, while they love this friction-free experience, they do expect that it doesn't come at the cost of privacy and security. Amazon Bedrock offers a comprehensive responsible AI and data protection set of features with things like encryption and governance. And by using Amazon Bedrock guardrails, customers can provide or can implement content policies and behavior boundaries to ensure that customer has a good experience. All right, so now imagine the situation happening in an industrial environment where downtime is critical and can have a significant financial impact. This can cost potentially hundreds of thousands of dollars per hour. In order for these operators to respond to unexpected conditions quickly, they need access to specialized knowledge and as much data as fast as they can possibly get it. And so that's why we're excited to share our latest feature in AWS IoT Sitewise, the AWS IoT Sitewise Assistant, which is a generative AI tool that's built into AWS IoT Sitewise that provides concise summaries of operational data and alarms. And this helps customers accelerate their decision-making, improve efficiencies, and enable faster resolution times. I encourage everybody to jump in the console and give it a shot. OK, so now on to our third pattern for autonomy. So the International Federation of Robotics recently recorded an all-time high of 4.2 million robots in factories worldwide. However, robots are no longer constrained to the factory floor. A robot may have busted your dishes at a restaurant or brought you room service to your hotel room or even drove you here today in Las Vegas. However, to understand the potential of IoT data with AI at the edge for autonomy, we need to recognize the role that IoT plays. An autonomous system usually can be considered with three key attributes: the ability to sense, compute, and act. Sensors provide that real-time multimodal IoT data. That's data acquired through things like computer vision or motion sensors, temperature readings, and more. This data is required for intelligent AI applications at the edge to understand and interact with the world around them. When coupled, and this generates a ton of data, and to give you a sense for how much data a single self-driving car could generate between 10 to 100 terabytes of data per day. So in order to make a real-time decision, you need to be able to process that data immediately. And to do that, you need to have the right amount of edge compute. And that's one of the interesting trends that we've seen over the past year is the advancement of these AI-accelerated edge compute devices. These chips are small, they're powerful, they're energy efficient, and they enable real-time AI on devices. Processing that data locally is really required for autonomous decisions, and so they can make decisions instantly. Think of situations where milliseconds matter, like a robot that's operating with humans or an autonomous vehicle that's driving you around the city. Now, when connected, intelligent applications that are running at the edge can leverage the optimal combination of onboard, low latency local inference for those immediate decisions with more powerful cloud-based inference in the cloud for more complex decisions that need that systems level awareness. And one company that's really at the tip of this innovation is Collaborative Robotics. So Collaborative Robotics recently launched their new robot Proxy, which is a robot that is designed to work with humans and fit the world around us. It's been purpose-built for human-robot collaboration with intuitive and dependable interactions. And it's in production today in places like logistics, hospitals, and manufacturing operations with a variety of use cases to move those boxes, totes, and carts. Cobot designed their robot from the ground up to incorporate AI and robot intelligence. So as AI technology advances, Proxy will be able to continually learn and adapt, and those new features are enable the robot to get smarter with every single update. And that's a blend of the local onboard intelligence, give you a sense for what's happening on this robot, It's a blend of the local onboard intelligence with visual perception to navigate environments and interact with humans in real time, and then the cloud-connected AI with access to the foundation models. In this case, Cobot leverages Amazon Bedrock for more complex decision-making with that systems-level awareness. All right, so here's the final reference architecture that we'll go through today, and this is for bringing intelligence to the edge. So for this one, let's use an example of a robot food delivery service. It's headed to your university research lab with some pizza. So the robot, doesn't end up in a fountain or a drainage ditch. You want to make sure that pizza is not too cold. It needs to make real-time obstacle and hazard avoidance decisions. And this could be under potentially disrupted networking conditions. So on the left of this architecture, you see the robot uses AWS IoT Greengrass edge runtime to deploy and manage local machine learning models. So that's for things such as computer vision, to make those instant decisions and interact with a local autonomy stack. To continuously improve that model over time, you're able to collect that real-world data from obstacles and failure conditions, the situations that the robot is encountering, with all the associated video and images that the robot's capturing. That can be streamed back into AWS using AWS IoT Greengrass Edge components and pre-processed at the edge, and it's using our secure credentials to do that. When combined with business intelligence and data in the cloud, this can support further training, fine-tuning, and optimizing models for the robot. And Amazon SageMaker offers over hundreds of pre-trained models to start building with, and a full suite of ML tools to build those MLOps pipelines and deploy your models down to your devices. So this are models such as things for hazard avoidance that you could build off of. Now with a well-trained model, the delivery robot will avoid most hazards. But what happens with an edge case or a failure condition? Maybe you hit a farmer's market that was on a regular delivery route, or there's a parade and the food delivery robots, maybe there's a mascot that's kind of trying to get in front of that robot. How do you account for those types of edge scenarios? Foundation models in the cloud can offer an escalation path and can inspect and improve the overall efficiency of the fleet. And this is outside of that individual robot or situation. This enables the robot to adapt to new scenarios, and human operators who are responding to those scenarios, they can respond to the failure conditions more quickly. All right, so you want to get hands-on? We have a dedicated workshop with our Edge partners happening today at 4 p.m. So in this workshop, you'll get to learn the end-to-end AI solution using AWS Edge and cloud tools. So you don't want to miss this one. Come check it out and get hands-on with these Edge tools. Okay, so it's been an exciting year for generative AI on AWS. Today, tens of thousands of customers and partners are already using our generative AI framework. And this spans virtually every industry, from healthcare and logistics to retail and manufacturing. Customers like GE Healthcare, BMW, Adobe, the PGA Tour. And personally, the other day, I was playing around with building a web application to connect to IoT sensors. And what used to take me a week only took me like an hour and a half to build a very similar application. It was really enthralling. And it really set that it's truly never been a more exciting time for builders to unleash their creativity. So to close out today and to summarize, today we explored the potential of generative AI when powered by IoT data. These cutting-edge tools and patterns that empower you to harness this technology right away on AWS. At AWS, we have the most comprehensive set of machine learning services designed at the optimal price point for a variety of virtually any use case. We're investing in a zero ETL future, so that means all of that IoT data becomes easier to connect and process, and it can be leveraged with your AI/ML pipelines more quickly. Our offerings are proven in some of the most demanding usage scenarios, with over 2 million customers using AWS database analytics and AI/ML services today. And finally, we offer multiple ways to get started, and that includes training, enablement, and a global network of thousands of partners and independent software vendors. All right, so I want to leave you with one final thought today. we really stand at the beginning of the era of AI. And this is a shift that will reinvent virtually every aspect of our lives. Technology, when you combine generative AI with real-world IoT data, can help pave the way forward in addressing some of humanity's greatest challenges. Think of things like climate change and clean energy, food and water scarcity, education, healthcare, and natural disaster response. And even if these solutions only scratch the surface of their potential, we could be on the cusp of an era of innovation that will harmonize the physical and digital worlds and provide advancements that far surpass anything we've seen before. So together, I'm really excited how we can shape a future where human potential is amplified by AI, unlocking new frontiers of creativity, productivity, and progress. So with that, I want to thank you very much for coming to our session, and we hope you enjoyed it today, and have a fantastic re:Invent.